Thank you for coming. My name is Reg Ash. I'm the CEO of Western Fair District, and we are thrilled to be able to have you here today to hear a lot of really fascinating stuff from our friend and partner, Chuck Baresich from Haggerty Creek and Haggerty AgRobotics. So we're sitting here in what used to be referred to really uniquely named East Annex of the Western Fair District. And this was a surplus building at one point in time, as was the building that you passed through to get in here. And a few years ago, with the help of some friends of ours with Michael Keegan and Associates, and I know Pat's in the crowd, we came up with a white paper that led us to take this leap towards building the Grove at Western Fair District. And the concept behind the Grove is to provide space and bring some companies together and share some resources, some information, and really focus it in on agri-food and ag tech. And that is what has led us to be here today, and through our partners at the Roundhouse Accelerator, RHA, we have met Chuck, and we're quite happy that we've gotten to know each other, and you'll hear about our future projects together as Chuck takes the stage. 2 years ago, we submitted an app to FedDev Ontario and said, hey, we'd like to bring this Grove along, and with your help, we can accelerate some investment into agri-food and ag tech. And so we submitted it, and last year in January, we announced some funding from the federal government of $7.2 million, which is matched by another 10 or so from the 5 different collaborators that have made that project a reality. And when you walked in, you would have seen a couple of spaces that have been built so far, and we're well underway on a few others. And we're just extremely thrilled to be really connecting or reconnecting with our agricultural roots as an ag society, and focusing our energies on supporting the agricultural community in every way that we can, which again is something that we're about to launch with Chuck and his team at Haggerty. So with that, I'll turn it over to Chuck, and he'll take on the rest of the day. Thank you.
Thank you, Reg. And thanks to everyone for being here and for joining us today. So, again, my name is Chuck Baresich, and I'm the general manager and one of the owners, along with my brother, Justin, of Haggerty Creek, and our new company, Haggerty AgRobotics. And Haggerty started, actually, I want to pause a second. I didn't grab the clicker, Jason. So, let's not throw it. So we'll just see if this works. There we go. So we started our business in 2001. We grew up in the Bothwell area and started as primary producers. Started with a grain elevator and an agronomy company. And through that company, we were always involved in precision agriculture. I've always liked technology. Agriculture actually tends to be a very technologically innovative industry. And so through that course of the work, we have done agronomy with precision soil sampling, mapping, GIS systems, and every part of rate control and automation that you can put on existing equipment. And we, on our own farm, we have a cash crop operation as well. We've tried to use this technology to improve ourselves, to reduce workload, to do a better job as farmers. And automation and robotics is a natural extension of precision agriculture. So if you think about a traditional tractor that a person would have to drive, and as you move along that path and you say, well, now you put auto steer technology on that tractor, and then you take the implement that you're pulling and you automate that implement to where the operator doesn't have as much to do. The next logical step is a robotics and an autonomous system. That is where things go next. And we started this process in 2020. I traveled to Saskatchewan to take a look at the Raven OmniPower, and we acquired an OmniPower in 2020, as well as we started working on the Haggerty Romeo, which is sitting in the back there. And we also did work with drones and trying some spraying and things with drones. And we're kind of thinking we were happy with how this went. And then in 2021, we took a bigger step into the autonomous field. So we deployed the OmniPower again. We worked with the OmniDrive, the autonomous kit for a tractor. We further developed and worked on the Romeo. We also saw some demonstrations of the Nexus Goat, which is an autonomous weeder, and the NeoOz product. And through this process, we also built our staff and some of our teams and partnerships. And I wouldn't mind introducing some of those people that are here. So one of the key players of our team is Grant Elgie, and he can come up and introduce himself.
Hi everyone, I'm Grant Elgie. So I'm the Agriculture Innovation Lead with Haggerty Creek. So my role with the company is to lead the operation and adoption of the robots for Ontario farmers. So I actually go out into the field, learn how to operate the robots, and get them to use on Ontario farms. So the past year, I've been working extensively with the NeoOz robot and the Haggerty Romeo robot as well, and figuring out how to operate them, kind of figuring out what their kinks are, what their shortcomings are, and how to adapt to those shortcomings or solve them, kind of thing. So that's what I do at Haggerty. So thank you.
And standing at the back, and he's tall enough you can't miss him, is Josh Weber, who's Grant's assistant, so he's in the back. And then most recently we've hired Jason Garabo, who's our project manager. You want to introduce yourself, Jason?
Hey everyone, thanks for coming out to the open house. And thanks RHA and Western Fair. It's been a pleasure working with you guys, and it's really awesome to see the vision and the plan coming together. My name is Jason Garabo. I'm the project manager at Haggerty AgRobotics, and I'm a recent grad from Western University. I finished the graduate program of mechatronics there. And we also have some new hires here in the audience, Noah and Matt, if you guys could wave. They're gonna be working with us this summer. We're excited to work with you guys. So I like to say that many of us at Haggerty are very tech-savvy farmers, and for myself, I'm a tech-savvy aspiring farmer, and we really see these tools as the future of agriculture, if not for their ability to meet many of the challenges we're facing in agriculture today, for the sheer convenience that these tools are going to offer. And with that, thank you, and I'll pass it back to Chuck.
So as I carry on, I'll talk a little bit about what we did in 2021. So just to give people an update. So this is the Raven OmniPower. We use it for spreading 1,800 acres of fertilizer this spring, about 300 metric tons of lime. And the technology keeps improving. And through this technology, we feel we can do more. And as an example, in this video, one of the items that we did is we demonstrated using two machines together. And we think this is one of the futures of technology. And so the driver of the Terrigator, the yellow machine, they are actually in control of the robot. going down at the bottom of your screen. And so they can see what it's doing. What you don't see in the cab is the field computer that is in both of those machines is mapping the information together. So each robot or each machine knows what the other is doing. And so if the Terrigator spreads fertilizer in one place, the OmniPower knows where it spread that fertilizer and it will turn itself off and it will not overspread. So the two will work together. And when the job is done, when I present the map to the farmer, they don't know that, that there's two machines working. It all comes as one specific map. And so Raven is working very, very hard on this technology. They have a great team, and we actually have one of their team members here, Jason Wilner, if would like to say hello, Jason? Yep, all right. So he's in the back, and I'm very happy to have Jason here. So the other piece of technology that we used in 2021 was an OmniDrive, and we had this installed in our tractor and combine last year for about 1,000 acres of our corn harvest. And what this technology did is, if you notice that there's no driver in this tractor, and what it does is it allows the combine operator to summon the tractor on its own. And so when it's ready, the tractor will come up, and it will synchronize itself beside the combine, and the farmer, in this case it was my brother, was able to unload on the go. And surprisingly enough, this technology was straightforward enough that my brother was able to figure this out and kind of understand the oddities and the issues. This is a prototype system, but he was able to work with this as the way it was intended. And my dad was in the audience here, so he can attest to flipping the autonomous switch and working with that system. So it was a very exciting technology, and I think this is a piece of tech that is really going to develop as time goes on. And then the Romeo. This is the Romeo. We are actually spreading a field, running through it. And so we are quite pleased with this robot. There are very few machines on the market today that you can leave unattended in the field without someone there. And it has obstacle detection, and it has it has LiDAR, and it has ultrasonic sensors on it that it can detect if it's going to run into something. So we're very pleased with where this robot is coming, and we've actually sold one to be used as a mower. So we're quite excited about building Romeo number 2. Again, this robot has a geofence, so you map it out, you lay it out in the field so it will not leave its boundary, and when it's done its task, it will send you a message saying, "I'm done, come and get me." And Josh was able to use that soil testing, and he was able to deploy that robot into one field, let it do its testing, while he went to a different field with the Gator and operated it, and then the two of them met up at the end. So this is part of the future of where we see robots going. In the spring of 2021, one of the things that we realized at Haggerty is that we didn't know everything. There's a lot of things that we didn't know. And so we formed an autonomous working group. And what we did as part of this working group is OMAFRA engineers and specialists, researchers from the University of Guelph, various grower boards and associations. This is kind of how this group started. And we started by meeting on a Friday morning and talking about what the priorities might be and what we should be working on and how we should move this forward. This working group has developed. We've added industry and manufacturers to this group. They join us from time to time, either to listen in to what we're doing or to make presentations about their equipment so that we understand about how it can be used. And what we're doing with this working group is we are trying to identify the gaps that producers face. So we at Haggerty, we are very close to the farmer level, as are the OMAFRA crop specialists and the researchers. They're very, very close to the farmer level, and they can identify what are the gaps that farmers are seeing, and then we go to our other industry partners and we see, well, what technology is available? What tools are in place? What robots are in place? And how can we assemble these pieces together to solve farmer problems? It's a very exciting work. It's a very exciting thing that we're working with. And we use this working group to help develop our plans for 2021. And we started the project in 2021 with the Oz robot. We started in small 2-acre plots. That's how we decided that was the best way to organize it. We were very much focused on horticulture to begin with. We kind of saw that weeding and horticulture was the most important place. But we also did try it in nurseries and berries and other crops as well. The NAO-Oz works strictly off of RTK GPS. So you essentially will mark an A and a B point in the field, and it will navigate that field. We had great success with the Oz robot in terms of our research and our data collection. So, Grant spent a lot of time. He was a very patient person, which I appreciate, trying to determine which tools worked and which ones didn't. Some of the tools that NAO sent didn't work that well in our conditions. And so this is part of our job at Haggerty AgRobotics, is to figure out what tooling will work and what items do our farmers actually need. And obviously, farmers in different parts of the world, we all farm differently. So part of this process that we're into is trying to determine logistics and how do we get these robots to the field and how many acres can they do and are they reliable and what modifications do we make. And luckily enough within Ontario, there's a great amount of knowledge between the university researchers, between OMAP staff, between the manufacturing sector to give us that advice and that consulting. So we're actually quite blessed to be where we are. We have such great resources. Ontario is also special because we have lots of different crops, all within a 2-hour drive. So if we want to see, traditional crop farming, we can go and see that easily. If we want to go and see Brussels sprouts and carrots and cabbages, we can go and see that as well. So we're very lucky in Ontario to have such a diverse marketplace. And as I mentioned, some tools are successful and some aren't. But it was a lot of fun to watch these robots working. And what it showed to us is that the concept will work. There were some kinks in the robots. We had some things that we had to fix and some things we didn't know, obviously at the start, but we learned a lot over the course of the year, trying to determine what is the best tooling. And in a robot like this that can eliminate 90% of the weeds without chemicals, that's quite exciting. And that's kind of where the future of these go. We are very happy with the weed control that they provided. And as I mentioned, a lot of the farmers in Ontario are quite intelligent. So even though we didn't know the tools, we didn't have all the information, a lot of the times we could take a tool that a farmer was already using and modify that tool to put on the robot. And that way the farmer only had to learn the robot. They didn't have to learn a new tooling system or a new set of skills. They were able to just transfer their existing knowledge to a robotic system. And as an example, what we saw last year, when we looked at a field, we had 70% or close to 80% of the weeds were removed in one pass of the robot. And by the second pass, 98% of the weeds were removed. So we were very, very pleased with the success. So we kind of feel that a cultivation type robot can be very successful in the operation. Now, typically we would not leave the fields to be, super weedy. All of these robots need the weeds to be small. That is the key to this technology and how it's going to work. And that is one of our learnings. So just to kind of move on a little bit, the NAO-Oz robots are what I call a micro-scale robot. So a robot that can handle about 2 acres a day. So an Oz robot used by itself is designed for a 10-acre plot. And that's kind of where these fit. And so you'll see that other robots will kind of fit into that space that we're working with. The next size up is what I call a small-scale robot, and these robots are for 50-acre fields. They will do between 10 and 20 acres a day, is typically, and that's where the dyno that's sitting back there, that's where it fits in. The idea of that robot is that you would deploy it every day for 6 to 8 hours a day, on whatever the battery will last, and then that robot will go through the field around 5 days a week, and then the next week it just starts over again. It is a different approach to how farmers are traditionally weeding their crops. Farmers today are very used to taking their tractor out and weeding the entire 50 acres in one afternoon. However, they don't have the labor to get that done. And the idea of the robot is that they don't have to be they can be doing something else rather than riding in a cultivator. So it is a bit of a different system, and that's one of the things we're trying to educate farmers on and to show them how this can work. The last size of robot is the large scale, the ones that are designed for over 200 acres a day. And there's definitely a place for these robots. This is where the Raven OmniPower fits in. This is where the autonomous driving kits for traditional farm equipment comes in. So there's going to be a place within agriculture for all of these. And with Haggerty AgRobotics, we are representing all of them. We're trying to figure out where all these robots fit. And for 2022, we're pleased to announce that we have 2 of the Raven OmniPowers for 2022. Both of these OmniPowers will be deployed commercially. So they are not being deployed on a test or on a demonstration scale. They're actually being deployed. So one of them we're using at Haggerty Creek. We have purchased a telehandler. We're going to be using it for spreading lime. Lime is a very bulky product. It typically involves having 2 people. One person driving a loader, the other person driving the interrogator. And the challenge with that in the springtime is it's difficult to have 2 people to do that job in a very busy time of the year. So what we're doing now instead is the person who is driving the telehandler pulls the robot out with them. So they bring the robot with them to the field. Telehandlers are designed to tow heavy loads, so they are going to pull this robot to the field. And the operator of the telehandler controls a robot in the field scenario. So we tried this last year. We had success doing this. The second OmniPower is being rented to another commercial elevator who also spreads a lot of a bulk product. And so they're renting the other one, and they have a very similar model. And it's that location is just outside of London. So both of the OmniPowers will be just within probably an hour drive of the London area. So we're very excited about that, to have both of these units in operation. Our autonomous working group is continuing. It is evolving in 2022. I won't go into it a lot in a large amount of detail today. But one of the things that we're doing with the working group is we are building an innovation lab or an innovation hub. So we are trying to formalize the trials and the research work that we're doing, and we are separating this into a subcommittee to have a more permanent location, to be able to collect all the information and have some more structure to what the working group is doing. And what the goal of the innovation hub is to help establish Ontario as a basis for ag robotics and ag tech, wherever that happens to be, and to take the information and the great work that's already being done and to try to get that work across the finish line and into farmers' hands. That's really what we're after with this innovation working group. Our robotics company for 2022 is pleased to represent several different manufacturers for this year. And I have them on the list, and we have we can talk about them more in detail later on. So for 2022, we're going to continue with the Oz robots. We sold both of the Oz robots we had last year. We have 4 new ones coming. The farmers are very excited to get them. And they're being deployed in a market garden and strawberry berry nursery type operations is the most common application where the Oz robots are going to go. The Nio Dyno that's sitting out back, Its new home is going to be just outside of Schaumburg in the Holland Marsh is where it's going to spend its time. And so that's where it's going for 2022, going into a horticulture crop. One of the things that's a little bit different about the dyno that I didn't mention before is that the dyno uses a camera on it to actually guide the tooling. But that camera can be used for other things. And so part of the process of using this robot is going to be what else can we measure on the crop, at the same time. This is just a little video of what the dyno looks like when it's running. So we got the dyno very late last year. It didn't arrive until October. So we didn't have a lot of time to work with it, other than to figure out that we were able to get it to work in our conditions. I think that was part of the challenge. Starting in July, NIO has built a new robot called an Oreo. So this robot is coming in July. The difference between the Oreo and the dyno is that it has a little bit longer battery life. It has a kilometer-an-hour higher ground speed. And it has one of the issues that we ran into is that the communications devices that these robots use are different in North America versus Europe. And so in order to meet the CRTC standards for the frequencies, the dyno robot doesn't meet the North American frequency codes. And so NIO has produced a new robot specifically designed for North American farmers. The other difference with the NIO product, with the Oreo product, is if you can see in the middle, it has space to carry a seeding unit. So they're able to mount seeders on this robot so we can actually seed a crop as well as weed at the same time. So we're very excited to have the Oreo coming. And the plan is for late August to have a TED robot here from NIO as well. So NIO originally started actually with the TED robot. That's where they began. And this is a robot designed for vineyards. And what it's used for is used for weeding underneath the vineyards, as well as used for doing yield assessments, for doing pruning and de-leafing. That's what the TED robot is for. And we have some other proposed uses for it, but we're quite excited to have this robot. It'll be the first one in North America. We're very excited to have it here. We saw a lot of interest in this robot when we were at the Fruit and Vegetable Convention a couple of weeks ago, or about a month ago. So one of the things that we're doing with this robot, if you noticed, is I'm talking about sensing. So one of the things that we're doing at Haggerty AgRobotics is we are mounting different sensors on these machines. And so one of the sensors that we're using is this Augmenta sensor. This is a multispectral camera that gets mounted on the robot. Because one of the questions that farmers have is that if I'm not walking through the field anymore, I don't get to see my crop like I used to. And so this is a way to address that challenge. And so what the Augmenta sensor does for us is it automatically takes pictures. So every yellow little triangle on here is an automatic picture that the Augmenta sensor takes a shot of the crop. And it uploads this to the cloud that the farmer can now look at. At the same time, it is analyzing the health of that crop using its own algorithm. And if it sees something that doesn't belong, if something is out of place based on a parameter that you set, it will take a picture and an image of those anomalies. And that's what the red images are. What's nice about this sensor is that this process is completely automatic. It requires no user input of any kind. And so now we can give the confidence to the farmer that they will actually be able to understand their crop better than they did before. That is one of the goals of the robotic space. The other piece of technology that we're looking at is using UVC lighting and other technologies for disease prevention. So Cornell University, in conjunction with a Norwegian company, developed a UVC light system for vineyards that shows great promise in non-chemical treatment of certain diseases in a vineyard crop and in a strawberry crop and other berries. And so there's a lot of potential in this. but these machines need to be run at night. So this is the kind of stuff that, you have to run it through the night in the dark. And there's lots of logistical challenges with your employees and your labor about if you're working all day, you can't have them running a light system at night. So this is another interesting project that we're very excited to be part of, is bringing this technology into the Ontario marketplace. A robot that I was hoping would be here today, but didn't make it. It is coming sometime in April, is the Nexus. So the Nexus robot is built in Montreal, and we're getting 2 of the Nexus robots. One will be in the Holland Marsh. It's being shared with the farmer, as well as with the Muck Research Station of the University of Guelph. The other Nexus robot is going to a carrot farm of Mark Sorokas in Grand Bend. And we stuck with carrots to start with this robot because that's what they know the best. And what the Nexus robot does is designed to run 24 hours a day. And it uses a series of cameras on the robot to detect what is not the crop. So what the cameras do is they look at the field and you tell it, I am in carrots. So it knows what a carrot is, and anything that is not a carrot, the robot will pull out. So it has a series of mechanical fingers that will move to the weed, grab the weed, pluck it out, and then it uses a little burst of air to blow the dirt and the weed off of the fingers. This robot is currently capable of between 3 and 5 acres every day. What they're at about 85% efficiency. And what that means is that it's able to get about 85% of the weeds. So obviously in a very weedy field, you may have to go over the field twice, but the idea of this robot long term is going to be 100% chemical free. The likelihood for 2022 is that we will put a setup rate of herbicides down first, but then use the robot to manage it first. Some of the key chemicals that were being used in Ontario are actually, this is the last year. So for example, linuron and other chemicals, there's a push to not have them anymore. So I think the farmers have a definite need. So this robot is going to require lots of fine tuning and effort on our part. And we have, we're very excited to have some people hired to help work with the Nexus robot. We're very excited about this technology. It's made in Canada, which is wonderful. Actually, it's built it was originally designed in Mississauga, and the manufacturing is happening in Montreal. So we're quite happy about that. And then we have 2 other robots coming, and they're called a farm droid. So the farm droid is made in Denmark. It's a solar-powered robot. What's different about this robot compared to others is that this robot geolocates every seed. So it will plant onions, sugar beets, carrots, other crops, and it georeferences where every seed is. It plants everything in a perfect grid pattern. And then it knows where that seed is. And what it does then is it will use the GPS to go and weed that crop 100% chemical free automatically. The other thing that's nice about the farm droid robot, if you notice it, it has a large solar panel on the roof. This robot requires no charging. So you do not have to bring it back to the shed to recharge it. It charges itself. It can run between 20 and 22 hours on a solar charge during the day. The downside to it is that it's very, very slow. So like this robot is designed for about 10 hectares or 25 acres. So if you want to do more than that, you have to run more than one robot. We are unsure how well this robot is going to work in Ontario conditions. Obviously, it's brand new. So what we did first is we're deploying it into a sugar beet field just outside of Dresden. And the farmer has agreed to do this. And the reason why we chose a sugar beet field is because that's what this robot was originally designed to do. And we thought, for the first year, we should deploy the robot into this is what it's designed for. This will give us our highest degree of success. The second farm droid robot is kind of up in the air as to what it's going to be doing. There is some interest in onions, there's some interest in other crops, and we're actually looking for people that are interested in using it. And so we're very excited about this machine. Of an interesting note, in Germany and Denmark and France, where they're building these robots, they're building 25 of these robots a week, and they cannot build enough of them. That's how successful the deployment has been in Europe. So they're very, very, I think we're very confident about them and what they can do. And I already touched on the Romeo a little bit. So our Romeo that Haggerty Creek owns is going to stay with the soil testing. That's probably our primary goal for that robot. The only difference is for 2022 is we are mounting a soil sampling probe onto the back of that robot. Currently, right now, the existing operator has to manually take soil sampling probes to calibrate the sensor at the end of the sampling job. We would like to fully automate that, so that'll be our next step. So the Soil Optics company has developed some technology to tell the robot where it needs the soil samples. The Haggerty platform that they have already has the capability to send the robot to those location points. It's just up to us to develop the soil sample probe for the back. So that is going to be a project for us. The other project of the Romeo, so there's a wheeled version of the Romeo that's being built as we speak. So that robot has been sold to another farmer, and on the back of that robot is a row mowing device, a fully electric row mower. And so that mower on the back, what it is going to be doing is mowing in between a horticulture crop. So the farmer is planting a cover crop in between their primary crop, and then the row mower is actually going to maintain that cover crop to a certain size so it doesn't compete with the vegetable. And we're going to try that and see if it works. We don't know if it's going to work. We don't. This is where we're looking for cooperators. So it's quite an exciting technology. And then the last robot that's coming for 2022 is the Roboti. So this Roboti robot is they're sending that here. It's a little bit different in that it has a 3-point hitch arm in the middle. So you can fit an existing implement into this robot. So it has two 75 horsepower Kubota diesel engines in it. And the idea of this, again, is a 60-hour runtime on a tank of fuel is what the thought process of the Roboti is. And so you can take your existing implement, mount it in the middle of the robot, and run this. So the one cooperator that I have that is interested in this robot, they want to use it for cultivating of edible soybeans. So this would be more of a traditional row crop scenario. This machine can run faster because it has a diesel motor, so it can run between 8 and 9 miles an hour. And the idea of this is to try to get more done. Traditionally, the robotics that we're working with, a lot of them are focused on the horticulture sector, but we also need to look forward into what's near and dear to my heart, which is the field crop sector, and how do we move robotics into field crops? And this is a step of where we're going. So I'd like to thank you guys for coming. I guess we're in the execution, we're in the action phase now as a company. So we did a lot of planning and a lot of trials in 2021. 2022 is a year of we're going to get some stuff done. And we are looking for cooperators. We're looking for people who are interested in having machines in their field. And we're trying to grow our network. So whether you're coming from a manufacturing side or a research side or a farmer side, I think what we're looking for is collaboration and opportunities to work together. That's where we're at. And our team is growing, and we're very happy to be part of this. We're very happy to be working with the Western Fair District and RH Accelerator. And thank you very much. Now, does anybody have any questions? Oh, I see several. Okay, go ahead.
So with some of the robots that
So the Oreo robot has a hot swappable battery pack that you can switch out. So you can actually bring a fully charged battery to it and then take the depleted battery back. The Oz robot and the Dino are designed to be returned to a storage site. So the places that we're putting them is we are trying to put them somewhere that they are close so that they can be easily transported. The little Oz robots, what we had done before, because they don't travel very fast, is we just had like a little garden trailer basically to drive it up to bring it back to a charging port. But logistics is a really good question because logistics is a real issue, especially when you talk about electricity. Now, one of the things that I will tell you is that I really like, the more that I work with electric-powered robots, the more I like them. There's a lot of advantages to having electric power, so I think it's worth it for us as a group to try to figure that out. I had another question in the back there. Okay. Okay. Anybody else? Yep.
How do you manage like field variability? So like in a challenging spring where the field conditions may be too wet to dry healthy or whatever. What kind of insight you found with that work?
So I guess the first thing that we found is that sometimes farmers make things more challenging than they need to be. And so we're very used to, as a farmer, to just driving to the field and just adjusting to what we find when we get there. And the very first thing, when I first got the OmniPower, I had big plans that I was going to spread 200 acres of fertilizer that day, and I think we spread 50. And the reason why is I didn't know how to address the field variability. I didn't know how fast, they're asking me all kinds of questions. How fast do you want the robot to drive? Well, I don't know, I never really thought about it. And what about on the turns? How fast do you want to turn? What direction do you want it to go? How many pieces of headland? All these types of things that, kind of come to us intuitively when we get to the field. So one of the things that we do to address this is we have come up with some protocols for before the robot gets to the field. And those protocols are going to be, what tillage level is that field going to have? We need to have the farmer mark out, is there going to be a rut? Let's say from a pivot irrigation system, is there going to be a rut to traverse? Are there any known obstacles in that farm, and can they be removed? Like sometimes we as farmers will work around a sinkhole in the farm rather than fixing them because we're too busy to fix it. And so some of this logistic stuff needs to be addressed ahead of time. The ultimate solution, and I didn't include it in this slide, is there is a sensor that we can mount on the disc of the robot that will actually detect soil moisture. And what that will do for us is that will allow us to adjust planting depth based on moisture, but it'll also allow us to tell the robot to stop, right? And this is where the integration of the sensor technology matches the actual driving to turn this into a system that a farmer can trust. And so that is kind of like the robotics manufacturers are being very good at developing robots that can drive straight up and down the field. But they're kind of coming to us and saying, if you have any specific needs like this, they're not saying you're on your own, but they're saying, help us develop this because we only have so much resources. So we're actually taking that on ourselves to address these logistical questions. The other piece is a difference between like in horticulture. In Ontario, we are generally we seem to be more okay with more residue in the field than they are in Europe. And I know Grant ran into that several times with some of the harrows, that there will be like root balls and things that were plugging up some of the tools, which is why we had to use North American tools versus European tools. Okay. Anybody else? Hey, Patrick.
Do these robots, do they have base stations that they go back to, or if you're seeding, the amount of seed in the seeder may be less than the battery life of the bat? Like, how does that work, and how does it? Yeah.
So the answer is going to be it varies. So some of the robots will run until their batteries are dead, and so you have to monitor it yourself. Other robots, they know enough that they know enough that the battery is not going to take them the full loop, and so they'll stop and they won't go. So I think it depends on the machine. And then as far as determining, when to refill, that is again, it's kind of related to the other question, where that is we're being asked to help develop that. Because that, technically that is designed around the implement. So it's not just when am I out of seed, it's also what happens if a bearing goes bad? What happens if the tool plugs? The little Oz robots, for example, they know when a tool is plugged because they detect wheel slip, and they will stop and raise the implement and move and lower it again. So there is some smart technology built into these things. But when it comes to the implement side, that's where we come in as a company to help develop that technology to say, okay, I am now out of seed, I need to return to my home base. And the robots do have that ability to return to the home base. Sometimes the question is how they return there is sometimes an issue. And that's something that we have to address as well. Yep.
On that axis, can you adjust the height for ground clearance?
Yeah, you can. Yep. So it has different heights for the tool carrier, and then you have to recalibrate the system based on the height that you determined. So they have that built in to a degree. Yep. Go ahead. So yes, there are harvesting robots that are around. The harvesting side is probably the most complicated of any of them. And so we are not doing anything ourselves in the harvesting side for 2022 because we had to draw a circle around something. The harvesting robots there's some that are working in strawberries. There are also autonomous machines that can pick apples and peaches and pears. They're quite nice how they work. But they're very much in a prototype stage. They're not ready for development. The one that we are working with, there's a company called Muddy Machines out of the UK that is built an autonomous asparagus harvester, and we're working very closely with them, and we hope to have that here. Our plan is that it's going to be here for the 2023 season, and that'll be the next stage is the harvesting side. Oh, then we should be talking. Okay? So we are collecting basically everything. So we are collecting soil texture, so sand, silt, clay as a breakdown, up to about 6 inches deep. We are also doing all your macronutrients, so your P, K, phosphorus. We're doing magnesium, calcium, as well as the micros, organic matter, and a CEC calculation. We have also been working on the Romeo on how to calibrate it for a soil carbon estimation. And we did some work on that, and there'll be an announcement on that coming shortly. Basically, what we're trying to do is an estimation on soil carbon up to 12 inches deep or 30 centimeters deep as a baseline. And the reason why we're interested in doing that is that it'll give us 335 data points per acre is what we're after. So it's to be a very, very high accuracy on the estimation. Okay? Yep.
So where do you see existing equipment manufacturers interfacing with as this whole industry moves forward? Are they more interested in broadening, or is this going to be a specialty?
I think the robotics side is going to start in the specialty crop world. And I don't know what the big OEMs are doing because I don't work for them, but the market, they traditionally have not been in this space. right? They haven't been in this space before. I don't see them getting into this space now because it's so specialized. You know, like every farmer does things a little bit different, and you know, and so this is why we're so interested in multiple platforms. You know, each of these platforms can be customized. And as an example, like even with asparagus harvesting, like it's such a small market. You know, it's just not big enough for a big company to go after, which is fine for us. I think you'll see the OEMs. I think we're already seeing the OEMs. What they're doing first is they are trying to automate their existing technology as much as they can. So, you know, I did a presentation at the Ontario Ag Conference in January, where the rep from AGCO showed, like on the Fendt tractor, basically it does everything on its own. And actually, to be honest with you, like we have a Rogator sprayer that uses a vision camera to drive itself down the rows. When you pull back on the joystick at the end of the field, it turns around the headland automatically. Like it's almost an autonomous vehicle already. And that's all being done with Raven technology. So I think you'll see the OEMs focus on trying to automate as much of their own equipment as they can. That's what I sort of see. And the challenge with broadacre crops like corn and soybeans and wheat is that labor is a challenge, but labor is not a large cost. You know, if you have a tractor that can work 500 or 600 acres in a day, you know, labor is not the driving factor. But if you have a horticulture farmer that's spending $1,000 an acre to weed their crop, labor is a huge factor. So I think we're going to start with horticulture, but I think the industry will catch up to broadacre later on. Anybody else? All right, well, that concludes the formal part. Thank you for paying attention, and thanks for the great questions. You put me on the hot seat, and I'm happy for that. So our team will be around. We will be around the robots to ask us some more specific questions. I know that Grant is a great resource, so is Josh, to talk about how the robots actually ran and what his experiences were. So I'm going to put him on the hot seat for that. He actually probably has more robotic hours underneath his belt than I'd say anyone around in terms of the actual number of hours running a robot. But if you know, I'll be around, and thank you very much.